Oh, what's going on here? I seem to be controlling your screen. Excuse me a moment. There we go. Okay, hopefully you guys at home can all see my screen now after the strange start I had there. So I'm Martin, as you heard. I work for a standards organisation called the Bluetooth Special Interest Group. So we're the organisation behind Bluetooth, if you like. We don't make things, though. We don't make components or software or anything like that. We actually produce the engineering specifications that manufacturers all use to implement Bluetooth for their products. So they should all work the same way and be interoperable. That's the idea. So as I said, today I'm intending to go back to basics and try to help those of you who are new to Bluetooth to get started. So the Bluetooth of today is very different to the Bluetooth of 20 years ago. I tend to think of it now as a toolkit for both communication and positioning. The first thing to know, though, is that there are two forms of Bluetooth. There's Bluetooth Classic, which is the old Bluetooth, and there's Bluetooth Low Energy. Now, Classic is used for data transfer and for audio streaming. And in terms of topologies, everything involves point-to-point connections between two devices. So you'll be familiar, I'm sure, with streaming audio directly from your phone to your Bluetooth headphones, for example. Bluetooth Low Energy, on the other hand, is very power efficient and it's a lot more versatile. It supports point-to-point communication using connections, but also broadcasting from one device to an unlimited number of other receiver devices. You can also use it for presence detection and proximity applications where distance is roughly estimated and you kind of figure out that you are close to some point or object of interest. You can also use it for direction finding and determine the direction of another device from you very accurately, and with a couple of measurements you can find the intersection and determine a location to within 10 centimeters of accuracy when indoors. We're also working on a high accuracy distance measurement capability, so you can estimate quite accurately the distance between two devices. That's coming in a little while. And then there's Bluetooth Mesh, and that allows networks of tens of thousands of devices to be created in smart buildings. And last but not least, there's actually a new audio technology called LE Audio, which is coming really soon and which I wish I had more time to talk about because it's really quite amazing. You won't believe the things you can do with that, but that's not here just yet. The key thing for you to appreciate, though, is this. If you're planning to develop an app that uses Bluetooth to talk to another device, you have to know which Bluetooth variant, Bluetooth Classic or Bluetooth Low Energy, that device is using, because your app will need to use the same. Now, most commonly, you'll find yourself wanting to write an app that uses Bluetooth Low Energy. So we'll focus on this variant now. So I said Bluetooth Low Energy was more versatile than Bluetooth Classic, and here's one example of that. On the one hand, you can perform one-to-one communication over a connection. This will give you the most reliable basis for communication and the opportunity for the best security. And it's the most common way of using Bluetooth Low Energy. But you can also broadcast data in a connectionless manner. And this means that one broadcasting device, like the blue blob in the center there of my graphic, can transmit data which an absolutely unlimited number of other devices in range can receive concurrently. So it's enormously scalable with no inherent limit to the number of devices that can simultaneously receive data from the broadcaster. A device can be a broadcaster, a receiver, or it can alternate between these two roles. So once again, as an application developer, you need to know how the type of device you want to communicate with uses Bluetooth Low Energy, as this will determine how you must use it in your application. So for the rest of the talk, I'm going to focus on the case where we want to write an app that will communicate directly to one connected Bluetooth peripheral device. It's almost certainly the most common situation you'll encounter. So applications of this type will generally need to implement 5 steps, which are as follows. First of all, your application needs to determine whether or not any candidate devices of the appropriate type are present in range and available to be connected to. You'll then typically display a list of detected devices to the user and let them indicate the one they want to connect to. Your application will then send a request to the selected device to request a connection. And having connected, you'll initiate a conversation between your app and the other device, which will reveal more details about the device, its capabilities, and how exactly you'll need to talk to it. And finally, with the connection to the remote device established and everything about it you need to know having been determined, you'll interact with it in a variety of ways to exchange data, commands, and so on. So let's take a moment to understand how the detection of available devices works. Peripheral devices that are available to be connected to do something called advertising. This is a Bluetooth procedure which involves the device periodically broadcasting small packets of data that contain a little bit of information about the device. And because the data is being broadcast, any device in range can receive it. And for a device to receive advertising packets, it does something called scanning. For an Android application to scan for advertising packets from devices in the environment, it'll use a Bluetooth LE scanner object and configure it with various settings and filtering criteria so that you only receive packets from what seem like appropriate devices. Ultimately, scanning provides you with a list of Bluetooth device objects, and it's information from these objects that you'll present to the user for them to make a selection from. Now, once the user has picked the device they want to use, your code will request a connection. This is a simple step, and the key classes involved here are Bluetooth adapter, Bluetooth device, and Bluetooth GATT. Now, GATT, G-A-T-T, is a technical term which stands for Generic Attribute Profile, and you'll see it in some of the Android class names. Now, once your connection request has been accepted by the remote device, both it and your smartphone app are said to be in the connected state. Typically, once connected to, a remote peripheral device will stop advertising and no longer be visible to scanning devices. And by the way, here's some more terminology for you. The device which scans and requests a connection is known as the central device. The device that advertises and accepts a connection is called the peripheral. We sometimes also use the relative terms local device and remote device. So if you're developing an Android application, from your app's point of view, it's the local device, and the connected peripheral is the remote device. Now, every Bluetooth peripheral device exposes an interface which your application will use to interact with it over the connection. The details of the interface reflect the type of device that it is and its capabilities and features. And after connecting, it's common to perform something called service discovery, which delivers to the application information about exactly what the interface looks like. Service discovery allows you to double check that the device you're connected to is of the required type, and then to use the discovered interface to interact with the device. So a peripheral device creates its interface from a collection of standard building blocks known as services, characteristics, and descriptors, and you'll encounter these terms in the Android APIs. Between them, they form a hierarchy, with services at the top acting as containers for characteristics. Now, a characteristic is just a data item, which reflects some aspect of the device and the state it's currently in. Descriptors belong to characteristics, but they're optional. Now, when attached to a characteristic, a descriptor can provide extra information or the ability to configure certain characteristic behaviors, which I'll cover later on. And services, characteristics, and descriptors all have a UUID that uniquely identifies their type. So once you've acquired details of the connected peripherals interface, you can start to interact with the device, and you'll quickly realize that most of what you want to do involves characteristics and their values. There are various different things you can do. Most commonly, you'll either be reading a characteristics value or changing it by writing to it. You can sometimes also switch on something called notifications, and this results in the characteristics value being sent to your application over the connection, either at intervals regularly or whenever the value changes. but characteristics only support specific operations, so you won't necessarily be able to do all of these things. What operations the characteristic supports is part of its definition. So the way I see it, anything you're likely to want to do will fall within one of two broad use cases. And the first one is this, controlling things. So let me show you a quick video demonstration, and then we'll explore exactly how it worked. So here's something I created. This is Dogbot. And think about the 5 stages I mentioned. I pressed a button on my phone there, and that initiated device discovery. One has been discovered. It's being presented to me now. I select it, and I then connect to the remote device. Now, with my UI, I'm sending commands, which I'll explain in a moment, that let me request that the dog robot do all sorts of amusing things like wag its tail, shake its head. It's got scary red eyes, looks great in the dark. Switch them on and off, of course, and perhaps most importantly, even more important than wagging its tail, I can, of course, command the robot dog to move, and I can steer it and so on. So that's all happening over a Bluetooth connection. So back to the slides, let's find out how that works. So we'll start with the hardware. The hardware consists of a chassis with a microcontroller plugged into it. That's this thing here in the middle. I'm just waggling my mouse around. It's specifically a programmable device called a BBC microbit, and it is electrically connected with wires to motors that drive the wheels and a couple of servos for tail and head movement. And servos are motors whose rotation you can control the angle of. And of course, also the LEDs are connected electrically to the microcontroller as well. And all of these hardware components are controlled ultimately by code running on the microbit that uses its low-level hardware APIs. Now, in this case, the microbit microcontroller has a Bluetooth GATT service called the event service. And this contains a characteristic called client event. And my application writes values over the connection to the client event characteristic. It's basically saying this happened, something happened on the client, and my application is the client as opposed to server. The code on the microbit responds according to the value that was written. And this is how I inform the remote device what I want it to do, switching on the LEDs, wagging the tail, and so on. So let me briefly show you what's going on in my Android application code. We don't have a huge amount of time here, of course, but let's just get the general idea of what's going on there. So first of all, there are, of course, some permissions associated with Bluetooth use. You'll need to check the documentation to be sure what it is you need to do there. And there have been some changes across versions of API, versions of Android as well. So double check what you need there. Now, the way I tend to work, I'll just open that up a little bit. There are lots of ways of doing this. We all have our favorite design patterns and so on. I tend to place my Bluetooth code in 2 primary classes. I've got one that takes care of scanning and device discovery, and then anything involving connections or the use of connections goes in another one. That's my adapter service class we'll look at in a moment. Just up there. If we start with scanning though, so very straightforward. You start by acquiring a Bluetooth manager from the context, and from that you get a Bluetooth adapter object. Once you've got that, it's possible to start scanning. And basically you call start scan on a Bluetooth LE scanner object, which you get from the adapter. So there's me getting it from the adapter there. And when you call start scan, you have to provide 3 arguments. One is a list of scan filter objects. My list here is empty because I've not got any filtering requirements. There are scan settings, which you can choose from, which basically decide what the kind of balance between efficiency of battery use versus how quickly you discover devices is going to be. The faster you want to discover devices, the more aggressively you scan, you'll use a tiny bit more battery there. That's what I'm doing here because I know I'm not going to scan for very long, but you can also ask for the most efficient way of scanning, which will protect your battery if that's what you feel you need to do. And then the last parameter is a callback interface to which the results of scanning in the form of Bluetooth device objects can be delivered. So scanning is pretty straightforward, and I tend to put it on a timer so I can stop scanning after a certain period of time. Then this other class here, I always implement as a service. It's a bound service for all the usual reasons. But what I have here is kind of two sets of things. On the one hand, I've got basically a method per Bluetooth operation that I want my activities to be able to invoke. So this method here lets me request a connection. I'm actually using the Bluetooth, Android Bluetooth APIs here. So there's a class called Bluetooth GAT, which has all of the key kind of methods in it for requesting actions. But all of these methods are essentially asynchronous. So you don't get the result of the action immediately, you get a callback later on. And to receive callbacks, you need to have an implementation of an abstract class called Bluetooth GAT callback. So because of the way I created my Bluetooth GAT object, when I create it, I have to give it a reference to a Bluetooth GAT callback, and it then uses its methods to inform me of the outcome of the actions that I've requested. So if I call the connect method, I eventually get a callback to on connection state change, which is this method here. And I can have a look at what happened there. Did it work or did it not work? Now, what I do is I use a handler to communicate the outcome of all of these actions to my activity. So that's what's going on here. I'm creating messages I send over the handler to my activity. And if we look at the activity and the handler, this is where we start to see those 5 steps that I mentioned, kind of in all their glory. So here we can see a message being received that indicates that I've established a connection. So I move on to the next step and I request service discovery. And when service discovery is completed, I get a message to my handler and I have a look at what services and characteristics were discovered. I'm doing some validation here to check that it really is the right kind of device, and so on. And once I'm happy with that, then I'm going to allow my user interface to start doing things like write characteristic values so I can control the device itself. So that's a very quick look at some code. We move on. That was the Android code, but what about the code running on the microbit itself? Well, as Android developers, I guess in most of the time you're unlikely to be writing the code for the peripheral device, but doesn't mean that you can't if you're interested in learning about that stuff, because embedded software engineering it's a specialized branch of software engineering for sure, but there are some amazing tools which can make life a lot easier, and it makes it a lot more fun, and you're going to learn all sorts of stuff. So for this particular robot dog control code, I actually used a web-based tool from Microsoft, which if I fire it up in my browser here, maybe just make that full screen. This is what MakeCode looks like. And if I create a new project, just to give you an example of what's involved, it has a kind of GUI view and a text view. It uses JavaScript behind the scenes. To do stuff with Bluetooth, there's an optional extension package, which I need to add. Searching for it here. There it is. So I add the Bluetooth package, and once I've done that, it appears here. You can see I've got various blocks to do with Bluetooth. Now, if we go back to my list of things I prepared earlier, here's Dogbot. Now, Dogbot is a relatively complicated MakeCode project. Most of it consists of a big event handler block. You can see things going on there. It's actually easier if I switch to the JavaScript view, because you can see really I've just got a load of functions. You can see things there which are clearly designed to respond to the various actions that my Android app can request, like shaking the head there. And I'm using low-level hardware APIs to make the device respond in the way that I want over those electrical connections. But mostly it's a big event handler which responds to messages sent from the Android application. In other words, values written to that characteristic. So that's what's going on there. It's really easy to use once you get your head around this, and highly recommended. If nothing else, it's good fun. So moving on, the second broad use case, if controlling things was the first one, the second I call monitoring things. This is all about acquiring data from other devices, and it includes the use of sensors, for example. So let me show you a quick demo once again, another video, where my application is going to acquire accelerometer data from the sensor in a BBC microbit in real time. Here it goes. So the same 5 steps. So I've discovered a BBC microbit, which is in my hand there. You can see it there. Those things in the background, by the way, are called books. You might remember those, some of you anyway. Now I'm connecting to it. There we go. And immediately I've gone through the other stages of service discovery. I've enabled things called notifications, and accelerometer data is streaming into my application, being handled and turned into the real-time charting that you can see before your very eyes. Pretty cool stuff, I happen to think. So let's stop there, go back to the slides and find out how that works. So the hardware is straightforward. It's a BBC microbit, and it has an accelerometer inside it. The remote interface exposed for Bluetooth use involves something called the accelerometer service. Now, this contains a characteristic called accelerometer data, and it supports notifications, which when they're switched on, results in X, Y, and Z accelerometer values being transmitted over the connection as a series of composite X, Y, Z values. Now, much of the Android code is the same as in the last demo I showed you. So, you know, we discover the device, we connect to it, we perform service discovery, validate that it's the right kind of device, and so on. But when that finishes, we enable notifications and process them as they arrive. So let me quickly show you some of the code here. So where things are different is actually in my handler, where just get orientated here. Yeah, after service discovery has completed, the first thing that I do is call a method in my adapter called set notification state, and that uses the Bluetooth GATT object that I mentioned earlier on to call a method called write descriptor. Now, whether notifications are enabled or not is controlled by a descriptor that's attached to the associated characteristic, which in this case, as I said, is the accelerometer data characteristic. So once I've enabled notifications, what starts to happen is I start to receive notifications within my Bluetooth adapter service class, and they get passed over to the activity as a message. So they get acquired here, and I simply extract the value from the characteristic notification, which is a byte array. And because I know the structure of the field, I can turn that into my X, Y, and Z values, which I then chart. So a lot of what's involved in here, as I said, is exactly the same as in the other application, just handling notifications. That's a little bit novel in terms of what we've seen so far. Now, as for the device code is super simple. I don't even need to go into make code to show it you, because everything is shown here on my slide. I've got a block that instantiates the accelerometer service. And as you can see, in addition to that, the only other thing I've got is a couple of event handlers that tell me when a connection was established or we lost the connection. Once the accelerometer service, if I can say it, has been instantiated on the microcontroller, that's all that needs to be done by us, and the rest is taken care of by the microbit runtime framework and the Bluetooth stack. Now, you may be asking yourselves, but how do I know what the peripheral's remote interface looks like? Because that's what you need to program against. Now, we're aware that service discovery will yield information at a technical level, but is that enough to allow an application to be developed? It's a good question, so let's talk about that next. So the short answer is that you can do a lot programmatically through service discovery, but usually you need more information than just what the interface looks like from the outside. So services characteristics and descriptors are either standards-based and defined by my organization, the Bluetooth Special Interest Group, or custom, and they're defined by the manufacturer or developer. A device interface might consist only of standard elements, or it might consist of a mixture of custom elements and standard elements. And in either of these cases, the best possible source of definitive information is, of course, the set of applicable specifications, which you should try to obtain if possible. Now, Bluetooth Special Interest Group specs are freely available to anyone from our website, and the URL for the specifications list is on the slide. Here you can see the specifications for various services and profiles. Now, I've not mentioned profiles so far, but these are specifications which define how clients must behave, and this includes which services and so on are needed on the remote device and the precise rules for how they must be used. They really define how particular product types are to be used. So you should find and review the applicable profile specifications if working in an area where standards apply. If you're working with custom services and so on, you'll need to see if the manufacturer have published details or not. Now, with or without the applicable specifications, there are various tools that can be invaluable. On screen, you can see two that I use the most. On the right, you can see a smartphone application called NRF Connect. It's free, it's available for both iOS and Android, and I use it all the time. It will discover any advertising peripheral, let you connect to it, and then discover and display the services, characteristics, and descriptors that the device implements. So it's perfect for discovering the interface details. And on the left is a protocol analyzer that I use to capture and analyze the communication which takes place between devices. So I'm going to close with a brief summary of the things you need to know about Bluetooth Low Energy and security. This is a topic I get asked about a lot. Now, first of all, devices must be paired for any of the security features of Bluetooth Low Energy to be available. Pairing is actually not mandatory with Bluetooth Low Energy devices in general, and whether it's used or not will vary by device type. So when two devices pair, though, they end up in possession of one or more security keys, and one of the keys allows the link to be encrypted so that all data over the air is safe. Another key supports a privacy feature where device addresses that appear in transmitted packets are disguised and changed every few minutes, so your device cannot be recognized and tracked from these packets. In addition, the device designer can opt to place permissions on characteristics that make access dependent on the device having been paired, and maybe even the precise way in which the devices were paired. Security is, of course, a big subject, but the key thing to know is that the peripheral device acting essentially as a server will largely dictate the security rules, and your smartphone stack will take care of most of the details for you. There's usually not anything you need to do in your code, but you should certainly make sure you understand the security attributes of the device type you'll be connecting to. Okay, that's more or less it. I hope this was useful. I'll leave you with some recommendations for resources that will help you go further. So at Bluetooth.com, in the resources section, you'll find things called study guides. These are educational resources aimed squarely at developers. They each cover a particular subject area, all explain the theory, and provide you with the opportunity to do some hands-on work. So you get to see how the theory works in practice. Now, I've highlighted two. The one on the left relates most closely to this talk. And if you want to get much better acquainted with Bluetooth security, the one on the right will tell you everything you need to know. And it is designed for beginners. So if you know nothing about security, read that. The first module will explain all the basic kind of concepts and issues and terminology involved in the world of security before moving on to look at how Bluetooth addresses those issues. And in fact, in some detail, how they work. There's also a nice collection of papers and videos, some of which are related specifically to Android, and they're all there for you to enjoy. So that's it. Thank you so much for listening, and hopefully we have time for a few questions now, but if not, feel free to ping me a question over Twitter or however else you choose to contact me. Take care and have a lovely day. Thank you so much.